Object-oriented programming, classes and objects in Java. So we are talking about class, and in object-oriented programs they are full of classes. You are creating classes, and the libraries are providing classes to use. So classes are basically containers that model real-world concepts. So we can have classes for rockets, passengers, cars, fruits, houses, whatever you need in your program. If you are building a game, then there are probably class for a player and the enemy. And let's say you are collecting diamonds, or then there are diamond classes and these kind of things. And the classes have both data and functionality. The data is in member variables, and the functionality means the methods the class is implementing. And programs consist of numerous classes that have their own responsibility. So you have a big program, might be hundreds of classes, even thousands, and all the classes they have their own responsibilities. This means that every class has its own responsibility and no other class is doing the same. So only one class should write to the log or open database connection, etc. And the class should have basically only one or two responsibilities. If the class is if the class is too big, so it has several responsibilities, then you probably want to divide it into two classes or three classes. And in object-oriented programming, the class name should usually start with uppercase letter. So we have a public class rocket with uppercase R, and the class is saved in a file called rocket.java. So the class name is the same as is the file that it is saved. And of course, when we are talking about C, C++, Python, Java, uppercase and lowercase are separate things. So these languages are case sensitive, so you cannot have rocket.java with lowercase letter R. It should be with uppercase letter. And classes, functions, and variables are usually named so that the code resembles text in English. So we are not writing our code in Finnish or in Russian or in German. We are writing it in English. So the variables are like a rocket or a car. So there is no Luftwaffe or mjölk or talo. So those non-English words are not used in programming. Of course, companies, frameworks, game engines, or any other tools and libraries and techniques, they have their own style guides you should follow. These points I just presented are very common, that are basically present in every framework or guideline. And when we are building a class, there should be always a constructor. And the constructor initializes a new object. So in Java, if you build a class that does not have constructor, then Java will automatically create a default constructor. But it's usually you want to have a better constructor than just a default one that takes no parameters and basically does nothing. And the construction is of course called when someone creates an object with a new command. So in Java and in C++, there is this new command that creates a new object. And the constructor is basically it's a method, but it doesn't have a return type, not even void. So constructor is not returning anything, it's just creating the object. And it's named as is the class, so if the class is rocket, then there is a constructor called rocket. And as said, there is this default constructor that takes no parameters, but you can have as many constructors as you need, but they need to take different parameters. So we can have a constructor for rocket class that takes parameter of astronaut. So it takes one or more astronauts as a parameter, or then can be a rocket that takes the constructor takes parameters cargo, and it takes an array list of cargo. These kind of things. It can have several ints or only one int parameter or whatever. And that's the responsible of a developer to design what kind of a constructor you should have. For example, we might have an object called company. So we are creating a new company with this new keyword. And there probably is the company is active, it might have a CEO, etc. And then it might go to bankruptcy. And that's the life cycle of the object. So when we are creating this object, the company, it might have its address, name of the CEO, and they can be given as a constructor parameter. And then the constructor builds the object so that it has address and it has a CEO. And yes, there can be multiple constructors. And these are just simple examples. You are taking just parameters and storing them in the variable, member variable. But there might be some complex operations. So you might need some reserving some memory, especially if you are developing C++ code. Creating other objects. So you are creating a rocket that might include creating a rocket engine. So in a rocket constructor, you might have a command that you create let's say 5 F1 engines to that rocket. So we are building a Saturn V moon rocket. You might want to register to some services if you are building a Twitter client. When you are starting the program, it creates some object, and some objects want to get latest tweets from the Twitter API. So you are registering to that API. That might be responsible of constructor. Similarly, you might want to get some resources. You might want to access to database. So you create a database connection in your database object. You want to get some file, let's say an image from your mobile phone's memory. That might be job for constructor. And if you have a window object in your desktop operating system in Windows, Mac OS, or in GNOME or KDE, and then there is a window object that it will want to draw the window. It might be a job for the constructor. And these initialize operations are handled by each object. So if you are creating 3 windows, then there will be 3 different constructors building those windows. And all these operations mentioned above are things that constructor can handle. And then there is this cleaning up part called destructor. And Java doesn't have a C++ style destructor, but an object can have cleaning responsibilities. So we might want to remove from service. If we have a computer game and you are playing a, let's say, Counter-Strike on some server, and then you decide to quit the game, then the game sends a message to the server that this player has decided not to play anymore and quits the game. So the cleaning up part is important. So you want to free up some resources, databases, networks, file. If you have a lock to some kind of a database that you want to access and you have decided that no one else can access that database, you want to free up that and unlock that database. And this cleaning is left for each object once again. And in C++, this is of course extremely important because you need to manually free the memory, but Java handles the memory management automatically, so it's in that sense it's not that important. But programmer has to clean her own things. For example, this ending connection. So if you are building a mobile game, for example, and usually we want to show some messages telling that there has been some kind of success in any operation. So if you are quitting the game, then the game might say that bye bye, and then it means that the process has been successfully ended. A few words about Java memory management. So there is automatic memory management, which is different from C or C++. It's similar to Python, so programmer doesn't need to reserve or free memory. The Java does it automatically. And if you have a, let's say, rocket object, and then there is a case that no one is using that object anymore, then Java puts it into deletion. And when there is a need for memory, you need more memory, then the garbage collector removes unused objects. So this rocket gets written off from the memory. But if your computer or mobile phone or any other devices has a lot of memory, you have a let's say terabyte of memory, RAM memory, and then you can run your Java program for a long time until the garbage collector starts for the first time. And when it starts, it might take minutes of time when it's freeing all the memory. That's one thing that you need to note when you are working with Java. And it is possible to separately call garbage collector. There is a call system.gc, but it's usually not needed, and it does not specify the exact time when it is run. So although you decide to call system.gc, which you usually don't, you cannot tell the system that it should start the garbage collector right now. It will start it when it sees fits. So that's one reason why we are not building a rocket operating systems or satellites with Java. There might be this laggy garbage collector thing. But in mobile phone or desktop software or web server, Java is absolutely fine language. There is no problem with that. You have been using Android programs for 15 years and they are working well. And then one of the most important parts of this video is this variable visibility. So there are multiple definitions for visibility. We will cover a few here and few then on the next week. And usually member variables are defined as private. And methods, on the other hand, they are often public, not always, but often. So class should share as little as possible outside. So not everything should be public. And so far on this course, we have just building a classes that we haven't really talk about how should we handle this visibility problem, but now we are taking care of that. And the idea is to show only those methods outside that are going to be used by other classes. So in a rocket, we can have a method fly, and then the rocket flies, and we can call the rocket to launch, and then it call it launch, and then we can call fly, maybe. But then there might be methods like check engines. But we from the outside do not want to call that function check engine, but the launch method might call check engine. So it's first checking engine and then it starts to launch and fly. And then this check engine method should be private. So it's not visible to outside that class. And this means that when you are creating a public API to be used by other classes and programs, those are those methods that are public. And they are seen by the rest of the classes and rest of the developers. Let's have an example on these. So here is our program. We have the main class, which only has the main method, and then we have the rocket class. So let's add a new class here. Let's add an astronaut. Like this. And now this is a public class, we can use it, but this time we are not creating just variables, we are creating private string name. So our astronaut will have a name, it will be private. Similarly, he or she will have also age, and that is an integer value. And this is the basic class. Now we have a private, and of course this name and age are not used yet. And then we will build the constructor. So public astronaut. So the name of the constructor is same as the class. And this will take two parameters, string name and integer age. And now we will just set that this name equals name and this age equals age. Very simple. We could also have a default constructor that does not set anything. We could set that this is empty string and age is 0, and then this could tell user that there is values are not okay. So now we have an astronaut class, and let's do a one method more. Let's give the public method print info. So return type is void. This is not going to return anything. It's just printing the information of this astronaut. It's something like debug method, but and it will print hi. My name is and I am age years old. Yeah. So this is how you build a class. What is that I am missing here? Yes, semicolon. Yeah, so this is the basic class where you have private member variables and then you have the public method. So this method is public. Anyone using this class can use this method. We could also have some kind of private method. Two private things. So this is just a dummy method. It's not returning anything. And just printing a line. Yeah, so this method cannot be called from outside, but this can be. So using these classes and using objects. So object is like a variable, and it can be used, for example, as a parameter for a method. And Java has two types of variables. So basically we have these primitive ones, int, float, boolean, double, long, whatever. And then we have object, and they are created from classes, string, scanner, rocket, starbase, integer. We have also integer class, which is the object version of this int primitive. And you can create as many object types / classes as you wish. You can build player or computer classes, whatever you want to have. And you can access the inside of the object with the dot operator, which we have been using several times. So you are calling object.method. And you can access the methods or variables if there are public variables, which usually you don't have. You might have just some constants there. That might be the case. But you can only access to methods or variables that are public. So if there is a private keyword used before the variable, then you cannot access that variable. Let's have an example of this. So we have the class, now we should use the object. So let's get rid of these. We are not using rocket right now. Let's build an astronaut. So like this. And now we can use this astronaut has this method, for example, the sprint info. And now we are building an astronaut without any parameters to the constructor. Let's see. Values are not okay, so it's printing no name, it's empty, and 0 years old. So let's have a astronaut Jennifer, who is 33 years old. Yes, now we have a Jennifer and she's 33 years old. Then there was this method called do private things, and now the NetBeans is telling us that this is a private method, we cannot access it, so this program won't work. Yes, we failed. But these private things can be called, for example, from here. So do private things. The class itself or the object itself can access to this method. Yes. So this is how you use your own classes, your own objects, and this does not differ that much from using scanner, or if you are using a string, which is class. This is just a class and object created from that. Then a few words about getSet methods. So basically we have getter methods which are accessors. They are returning the value of a member variable, and the return type is of course then something else than void. And method needs a return command, of course, because it's returning something, and name begins with get. So you might have a rocket and you might have it then get cargo, so it's returning the cargo from the rocket. Then we have a setter methods, modifiers. They change the value of the instance variable. Usually return type is void or the object itself. So, and the name begins with set, and it can be, for example, set cargo, and it's inside rocket, so rocket can then have a cargo. And if we have this int get country size, so we have a method called get country size. It's probably returning country size, so area of some kind of a country, and it's integer. And we have set country size, that it's taking a parameter integer and it's storing the variable. And if this set method is returning the object itself, then we can have a chain of these set commands in the same line in the coda, and we will have an example on this one. Okay, setters and getters. So we have two variables. We would like to have setters and getters for these. Let's have them in here. We should be able to do that automatically. So we are now creating setters and getters. Here we have them. Let's move them here, and we do not need these right now. So basically we got do get methods which are returning string and int, and then two set methods name and age which are returning nothing, but they are getting a parameter. But this is a simple way. Now we have a setter and getter. But what we really want, we want to take care that this name could not be anything. It should be real name, and the age should be real age, not just a number. So let's first go with this age. So we are not allowing anyone to input any age. We want to take care that the age is suitable. So the age needs to be more than 0, and the age needs to be less than 130 years. Let's say we don't have older astronauts. And now it was not correct. Actually, let's not have it this way. Let's have it another way. If age is less than 0 or age is more than 130, then we can just print out that this is not right. Age is wrong. Return. So if you are inputting incorrect values, then we are not changing the age, but otherwise we are doing that. Similarly, if someone is trying to input bad name, give a bad name this, no, not here, here. If someone is trying to set a bad name, then we are not doing that. So if name is empty, then we are just printing out that name is too short. And return. Okay. And then I mentioned this, that we could use this return the actual object. So let's do a testing. Let's modify this, that this is returning an astronaut. So we are returning this, and here we are returning this, which means that we are returning this object itself. And similarly, this age is returning this, and here we have a return this. And now we need to just this astronaut like this, and there is missing semicolon. Yes. Now we could have an astronaut. Let's see how this is now working. This is still compiling, right? Yes. And then let's see what we have. Astronaut, we press dot and we get access to what this object has. So we have given it get name, get age, and we have also have this set age and set name. So let's modify the name, Maya, and then let's modify the age, 27, and now we can use this again. So first our astronaut is Jennifer, 33 years old, and then we modify it and we have a Maya, and she's 27. And now as we return this and this object itself through this keyword, we can set the age first, let's say 53, and then set name Mike. And now we are not seeing anything. Let's add this line here. Yeah, so now we can have these on the same line when we are returning the object itself. This is and one way to ease the programming. We can set all the variables on one line, but I'm not personally that fond of this, but it's something that you might see on some codes. And then if we would like to have a age that it's not valid, -3, and name that is, let's say, empty. Now nothing should happen as we have encapsulated our fields and we cannot access them and blah blah blah. So the age is wrong, name is too short, and so we still keep the mic and 53. Yeah, so we have now encapsulated these fields. So this is one key element in object-oriented programming, that we are taking care that these fields are private and they can be accessed only through get age and get name and get age. So if we would like to get the astronaut age, we can get it through age, but we can through get age, but we cannot access directly this age member variable. It's private. So it's now we cannot accidentally set age that it's not reflecting the real world human. So we cannot give age -3 or 2000 or something like that. We have encapsulated the field, and the only entry point is through this set age API, which is public, and it checks that the age is valid, and if it's not, it then informs us that the age is wrong. So, as a conclusion, Java is used for object-oriented programming. It's very bad in procedural programming, and it should never used for procedural programming. It's no go on that. Parts of a class are limited with visibility definitions like private and public. We will meet the new other keywords later. Class has a constructor that makes sure that the object is in the correct state when it's created. It can initialize some values, it can call other methods, it can create other objects. That's the responsible of the constructor. And objects are variables like int or float, but you can customize them as you wish.